Hello students. We have discussed time shifting, time scaling, time reversal, amplitude scaling, right? And signal addition, signal subtraction. And so today we will see how to do signal multiplication, right? So, so as I said before, so we are multiplying the two signals, right? So we need two signals to perform multiplication operation, right? So x1 of t is multiplied with x2 of t. The output, the inputs are x1 of t and x2 of t. This is the multiplication symbol, right? So this is the multiplication symbol. So we are applying two input signals. One is x1 of t, another one is x2 of t. So we will get output, right? We will call that one as response. So y of t is equal to x1 of t into x2 of t, right? So we will see one example how to do signal multiplication, right? So this is the original input signal x1 of t and x2 of t. So here we are performing multiplication operation between the two input signals, that is x1 of t and x2 of t, right? So here between the time period 0 and 1, it is a ramp signal, right? This is a ramp signal. So which means, so if it is the time is 0, the amplitude is also 0. If the time is 1, the amplitude is also 1, right? So we know that. So the equation is r of t into t. This is the functional representation of ramp signal, right? We know these things already, right? So now we are going to do multiplication between the time period 0 to 1, right? So in the x1 of t, it is a ramp signal. The x2 of t, right? So the amplitude between the time period 0 and 1 is the 1, right? The amplitude is 1. This 1 is multiplied with the ramp signal, right? So we will get again ramp signal only, right? So we are getting again ramp signal between the time period 0 and 1. So now I am going to multiply the amplitude between the time period 1 and 2, right? Here it is 0 0.5. So here is 1, right? So the 1 is multiplied with the 0 0.5. We are getting again 0 0.5 output, right? So again between the time period 2 and 3, the amplitude is 1.5. This 1.5 is multiplied with the signal x1 of t between the time period 2 and 3, the amplitude is 0.5, right? This 1.5 is multiplied with the 0.5. Again we are getting how much? So if the 1.5, right? So 1.5 is multiplied with the 0 0.5. We are getting 0.75, right? We are getting 0.75 between the time period 2 and 3. So this is the graphical representation of graphical representation of output, that is the y of t is equal to x1 of t is multiplied with x2 of t. Okay, so this is the discrete time representation. Okay, so how we are performing the multiplication operation in the discrete time. Okay, so if the signals are discrete, okay, so the representation is the discrete time representation. We are doing x1 of n, right, and x2 of n. These two are the discrete time input signals, right? These two signals are multiplied and we will get the output response y of n. Okay, so again here I have took two sequence, right? X1 of n and x2 of n. Just we have to multiply these two amplitudes, right? So 1 into 1 is 1. So 2 into 0 0.5 is 1. So minus 2 into 0 0.5 is minus 1. So 3 into 1 is 3, right? Just we are multiplying these two values. The first value is x1 of n, second value is x2 of n. We are multiplying these two amplitudes and we are getting the product. This is the output response. Okay, ma'am? It is very simple. Okay, so these are the exercise problems. So please solve these problems. Just for I will explain one or two problems. Okay, but you have to go through all those problems. Okay, water and all it is there in Ramesh Babu. Just do practice. Okay, it will be very useful for your exam. Okay, so sketch the following signal, right? Signals based on time reversal. Okay, so using the time reversal concept, you have to sketch the signal. Okay, so what is this? U of minus t plus 1. This is a unit step signal, right? So here we have u of, it is not a plus t, it is a minus t. So minus t plus 1. First, I have to write unit step function. We know very well how to represent graphically the unit step function, right? So u of, sorry, u of t is the magnitude of u of t is 1. So when t is greater than equal to 0, when t is greater than equal to 0, the amplitude of u of t is 1, right? This is the graphical representation of unit step function. Okay, how we are representing the u of minus t, right? Just we are reversing this unit step function, that's all, right? So this is the positive value of t. So just we are reversing this one with respect to minus t, because we have to find out u of minus t, right? This is the graphical representation of u of minus t, right? So now we have to do, so u of minus t plus 1, right? So what is the mathematical representation of u of minus t plus 1? So my, how we can, I have taught this one. So minus t plus 1 is equal to 0, right? So minus t is equal to minus 1, right? So when t is equal to 1, when t is equal to 1, the unit step function, the amplitude of unit function is 1, right? So you have to start from, you have to draw at t is equal to plus 1, right? This is the graphical representation of u of minus t plus 1. Okay, again, this one is the ramp function, you know very well, right? This is the amplitude, 3 is the amplitude of ramp function, or we can also call this one as alpha, alpha r of t minus 1. Okay, so we are graphically represent, first we have to graphically represent 3 into r of t. Okay, so the 3 is the value of alpha, right? So alpha we are representing, alpha is equal to the ratio of y axis divided by x axis, right? So alpha is equal to dy by dy divided by dx. This one is a dx, this one is the dy, right? So dx, how we are representing dx? x2 minus x1, right? This one is the x2, this one is x1, this one is x2, x2 minus x1. Similarly here y2 minus y1. So we are getting alpha. Okay, 3 into r of t, right? So how can we represent this r of t minus 1? So here we are getting the ramp function, okay, at when t is equal to 1, right? When t is equal to 1, right? This one is a 1, t is equal to 1, because we have to draw the graphical representation for r of t minus 1. Okay, when t is equal to 1, we will get ramp signal. Okay, similarly you have to draw, just solve these things in your home. Okay, if you have any doubts please ask me. Okay, similarly this one, okay, these are very very easy, I have already taught these things. I hope you will understand this concept. Thank you very much.